Hi, folks. This last set of concentration units that we're going to talk about is called molarity. And this is commonly used in chemistry labs. You're not going to hear about molarity very often outside of a chemical situation, but this is a chemistry class. And so we're going to talk about molarity. Molarity is defined as moles of solute per liter of solution. And so the units are very important. We're going to do some calculations with these. Don't hyperventilate because I said moles again. We're going to keep it pretty simple. But molarity of a solution is how many moles of solute are in liters of solution. As we have been doing throughout all of these concentrations, it is part divided by the whole. Now, the thing that is different with molarity, it's not a percentage. You'll notice there's no multiplier. We're not multiplying by anything else out here, not by 100 or a million or a billion or anything else. It is just part divided by the whole. When you're referring to a chemical concentration, there is a molarity number. The molarity is usually abbreviated with a capital block M, and the molarity depends on the solution you are referring to. Highly concentrated pure forms of a strong acid like hydrochloric acid can be 18 molar. That is very strong concentration. That often can be the strongest concentration that you can buy for a chemical lab. You and I can't go to the store and buy that, but a chemist could purchase something like that. If that is diluted down, been watered down for different uses, then you can buy something like a 6 molar solution, and it would be written 6 molar. If that is diluted down further, you can get a 3 molar solution, a 1 molar solution, a 0.1 molar solution, and it can become weaker and weaker and weaker. So this is just a more diluted situation. More water has been added in order to find the right concentration for whatever the chemist needs at that point in time. Now remember what a mole is. A mole is, if we take the molecular mass on the periodic table, the atomic mass on the periodic table, is equal to 1 mole of substances. Now that's Avogadro's number, 6.022 times 10 to the 23rd pieces. So if you take something like carbon and it has an atomic mass of 12.01 grams, if I take 12.01 grams of carbon, that means I have 6.022 times 10 to the 23 atoms of carbon. And that is 1 mole of carbon. And a mole is the chemistry unit of amount of substance. So it is very useful in a chemistry laboratory to actually count number of atoms, number of molecules, and relate that to any molecule that we might be working with. So let's talk about molarity of solutions. And we're going to go through a few examples that are pretty simple. We're going to start with sodium hydroxide. Sodium hydroxide is common a lye solution that you might use to make homemade soap or to declog a drain. So common sodium hydroxide solution is not an uncommon thing. You might actually have something similar to this around your home. But we're going to use this as an example of how molarity is calculated. So what would be the molarity of a solution if I had 1 mole of sodium hydroxide dissolved in 1 liter of solution? Well, if I had 1 mole of sodium hydroxide in 1 liter of solution, I would have a 1 molar sodium hydroxide solution. It's as simple as that. That is the definition of molarity. How many moles of a chemical are dissolved in 1 liter? So if I had a 1 liter beaker full of water and I happened to have within that 1 mole of sodium hydroxide, I would have a 1 molar solution. All right, let's change this up a little bit. Let's say that in the same quantity of fluid, I had 1 liter of solution, but I had 2 moles of sodium hydroxide. So 2 moles of sodium hydroxide in 1 liter of solution. It would be twice as concentrated, and I would have a 2 molar solution of sodium hydroxide. So it is a way of saying how concentrated this chemical solution is. Just to take it one step further, because I want to make sure you understand this, 3 moles in 1 liter, 1 liter beaker, 1 liter beaker, and I have 3 moles in there, 3 moles in a 1 liter beaker. What am I going to have? I'm going to have a 3 molar solution. So it is how much of this chemical is in 1 liter of that material. All right, let's change this up a little bit. So instead of having my 1 liter beaker, let's say I have half that size, and I have a 500 milliliter or half a liter of beaker. What is going to be the molarity of my solution? Well, then let's go back and use our equation. So moles of solute, I'm going to have 3 moles of my sodium hydroxide. Half a liter, 0.5 liters. And if I do this, I'm going to do 3 divided by 0.5. I'm going to end up with a 6 molar, and I indicate molarity with a big capital block M. I'm going to end up with a 6 molar solution. So the same amount, 3 moles of sodium hydroxide, but in half as much liquid is going to give me a much stronger solution. This is what a chemist would do in a laboratory. In a laboratory, which unfortunately ours is not a lab class, but if you were in a chemistry lab course and you were told to make a molarity of solution, you would first figure out what volume you were going to make. Then you would decide what molarity of that solution you were going to make. You'd go through some calculations, and we're just not going to go through deep calculations of molarity. You'd calculate exactly for a certain molarity, you would calculate how much mass of whatever chemical you were dealing with, sodium hydroxide or whatever else, and you would find that mass on a balance. You would then add this to a very specific, very carefully created flask. It's called a volumetric flask, one of my favorite pieces of glassware in a chemistry lab. It's got a big base, and then right around the neck, it has a line on it that you can fill to a meniscus just like a graduated cylinder. It lets you get very specific and careful volumes. You put the powder in the bottom, then you put the fluid, usually distilled water or deionized water, up to the top, and then you will have your mass in a certain complete volume, and you will have you can calculate from there the molarity of your complete solution. So it's pretty simple to do. Before we leave this idea of molarity, I want you to try a more complicated one. It's not deeply complicated, but it's going to mean that you're going to have you grab your calculator. So try this. 0.210 moles of sodium chloride are dissolved in 600 milliliters of solution. What is the molarity of the solution produced? So hit pause, try this, then we'll go through it. Okay, my friends, moles of solute. You're told the moles. You have 0.210. 0.210 moles of sodium chloride, plain old table salt, and then 600 milliliters. Now, Mary was tricky and a little bit evil because this is milliliters and this must be liters for molarity. And if that caught you, that's why we practice, so that you can make your boo-boos now before you do it on the study guide and the quiz. So milliliters, you have to convert that to liters, move the decimal 3 places. That's going to be 0.6 liters. 0.6 liters. If you did everything else right but just made that boo-boo, you are forgiven because that's the way it goes. And if you caught that, you get to do a big happy dance because that means you are extra with it today, and I am very proud of you. So 0.210 divided by 0.6 liters, that is going to be 0.350. How do you label that? Big capital block M for molarity. 0.350 molar solution of sodium chloride. All right, my friends, I think that is it for this time, and we'll see you later. Bye-bye.